Alright, here are solutions for perfect problem 4 for Math 213. The idea here is to come up with the formula for the surface area of a sphere. And you're told that the volume of a sphere is 4/3 pi r cubed. And the volume of a pyramid with base A and height h is 1/3 A times h. And yeah, we'll learn those when we talk about volume. So the way we're going to think about this is we're going to think about a sphere filled up with a whole bunch of these pyramids. So every pyramid has kind of its top in the middle here, and there's a whole bunch of them kind of filling up in here to fill up the entire sphere. Because the base is flat, they won't form a perfect sphere. It'll kind of look like a ball made up by a bunch of tiny little flat panels, I guess. But the idea is you can make those panels smaller and smaller, and it'll get closer and closer to a sphere. Okay, anyways, assume that you have a sphere of radius 10, and you're filling it with pyramids with a base area A equals 3, as shown above, not really above, as shown in this picture right here. Determine the volume of one of the pyramids. Okay, volume of the pyramid. I have this formula that tells me it's 1/3 A times h, but I'm told in the problem that A is equal to 3, and h is just the radius of the sphere, because each pyramid has its top, if you will, at the middle of the sphere, and its base on the outside of the sphere. So this would be 1/3 times 3 times 10, aka 10. The volume of the sphere, I think, is my next part. Well, the formula for a volume of a sphere is 4/3 times pi times the radius cubed. The radius in this case is 10. So I get 4/3 times pi times 10 cubed. 10 cubed is 1,000. So this is, I don't know, 4,000 pi over 3, I guess is one way you could write it. Other ways you can write it too. I'm going to leave it like that. Fine, this is the volume of my sphere. I got the volume of my pyramid, the volume of the sphere. Determine how many pyramids we'd need to fill up the entire sphere. Well, if we're going to fill up the entire sphere, we're taking this much volume and filling it up by things of this volume each. I would take number of pyramids is this total volume, 4,000 pi over 3. And take that whole thing and divide it by 10 to figure out how many of these 10s go in there. My answer there would be 400 pi over 3. And maybe I'll pull out a calculator. I bet you'd rather have numbers for these. So if I do 4,000 pi divided by 3, I get approximately 4,189. And if I do 400 pi over 3, well, it's going to be the same thing. Except move the decimal place one time, so maybe I'll say it's roughly 419. Okay, so I'd need 419 of these pyramids to fill up the entire sphere. So how can you figure out the surface area of the sphere? Well, 419 pyramids times is the number of pyramids, times whatever their base is. Their base in this case is 3. If I take surface area of the sphere is equal to this 400 pi divided by 3 times the area, the base area of this pyramid, which is 3. So I end up with 400 pi as my answer, which is close to I don't know, 1257, I guess. And these are units squared for my surface area of the sphere. And I think I'm not quite done. Okay, cool, I did all that, but now you want to do it again, but this sphere has radius r. So I can do the same basic idea where, I don't know, over here maybe. I can say the number of pyramids that I had was just the volume of the sphere divided by the volume of the pyramid. So I take 4/3 pi r cubed divided by, so that's the volume of the sphere, 1/3 times A times h, which is exactly the radius. The height is the same as the radius. And if you simplify that, what you'll get is 4 pi, what happened there? Oh, yeah. You'll get 4 pi r squared over a. So this is the number of pyramids. Number of pyramids is the volume of the sphere divided by the volume of a pyramid. So this tells you the number of pyramids. So the surface area is the number of pyramids, that 4 pi r squared over a, times the area of the base of each pyramid, a. Well, those a's cancel out, and I get 4 pi r squared as my answer. So I guess I did this last part up here, or this part over here, to get that answer. Not laid out as neatly as maybe you would hope, but hopefully that's enough for people to follow it. So I'll end that here.